So good morning. And we have an example here which also similar with the products of sine and cosine. Whereas in our um, example, we have a numerator of sine and a denominator of cosine. So if there were a product of sine and cosine, we would know what to do. We would strip out the sine. So since the exponent on the sine is odd, and we need to convert the rest of the signs to cosine. So it is also the same idea with uh, our example here, which is which also um, works as product of sine and cosine. So we will strip out a sine from the numerator, and we need to convert the rest to cosine as follow. So since our sine here has 7 exponent or odd exponent, we need to strip out one sine. Okay, so the first step is strip out one sine. So we have sine raised to 6x over cos 4x. Sorry, this should be on that. Then sine x dx. Okay, and the next step is we need to, again, we need to extract from our sine 2 raised to 3. Okay, why did we strip out again an exponent which is 3? Because sine squared x is also equivalent to our 1, right? 1 minus cos squared x. Then this is also raised to 3. And we have sine x dx over cos raised to 4x. Okay, now at this point, we can actually say that our cos x is our u. Okay, so at this point, all we need to do is to use the substitution u method, which is our u is equal to cos x, and we are done. It means that we have u is equal to cos x. And from our equation, we can say that our equation is equivalent to 1 minus u squared, right? Then over u raised to 4, then this is equivalent to its du, since our sine x dx is the derivative of our cos x. And take note, from this equation, we need to expand our numerator. Okay, by using, it's either you can use 1 minus u squared, 1 minus u squared, 1 minus u squared, then expand. Or you can use the Pascal triangle. So which means that is if it is in terms of cube, let's say we have a plus b raised to 3, then equal to, that is equivalent to a cube, then minus 3, then a, then 3 minus 1 is 2, then b, then plus 3, then we have a b squared, then minus 3 b cube. Okay, since our a here is 1, then our sign is equivalent to, sorry, this is a minus b. So we have negative sign, and we have b is equivalent to u squared. You just have to substitute the values. So we have 1 raised to 3 is 1, then minus 3, then we have A is 1 again. So 1 minus 1 raised to 2 is 1. Then we have u squared. Then plus 3. Then again 1 is A is 1. Then B squared is u squared. So we have u squared raised to 2 is u raised to 4. Then we have minus, that is u raised to 2. Then raised to 3, that is u raised to 6. So our equation here now will become 1 minus 3 u squared plus 3u raised to 4 minus u raised to 6. Then we have u raised to 4 and du. From here, we can say that we can apply the distribution of our denominator, since um, for the first part, or for the first term, we have, that is u raised to negative 4. That is also equivalent to 1 over u raised to 4. And we have minus 3, then u squared, then minus 4, plus 3, then u raised to 4 minus 4. And we also have u raised to 6, then minus 4. And for the final equation, we have u, then we have raised to negative 4. For this one, you have negative 3 u raised to negative 2, then plus 3 u raised to 0. That is equivalent to 1. Then we have u raised to 2. And don't forget our du. And when we apply integration from our equations, we can say that our equation is equivalent to the first term, that is negative 1/3, then u is to negative 3. Then we have here, that is 3, right? Then we have is equivalent to negative 1. Then we have u raised to negative 1. Then plus, that is 3u. Then minus, that is u raised to 3 over 3. Okay, and don't forget our constant. Okay, since our from our u is equal to cos x, we can simply say that our du is equal to negative sine x dx. So it means that our final answer will be multiplied by negative sign. So we have negative, and okay, let's just simply apply negative sign from our here. Okay. Apply negative sign, multiply the equation. So the final answer will be 1 over 3. Then u raised to negative 3 is equivalent to 1 over u. And our u is cos x. So we just need to substitute our cos x. So we have cos, and don't forget that is raised to 3x. Then we have negative times negative here from our second equation. That is positive, and multiplied by negative, that is negative 3. Then over cos x. And for the third term, we have negative 3, and that is cos x. Then for the final answer, we have positive. Then we have cos cube x over 3, then plus c. So it means this is our final answer. So um, to clarify things, under the right circumstances, we can use the ideas developed to help us deal with products of trigonometric functions to deal with quotients of trigonometric functions. Okay, so the natural question then is that what are the right circumstances? So it means if we simply put our original equation into another, let's just say that first we notice that if the quotient had been reversed as this integral, so it means that if our original equation is reversed, okay, over sine x dx. So we will then have been able to strip out a sign because if we strip out the sign, okay, if we strip out the sign x, that is equivalent to 1 over sine x, then dx. So it means that we can say that if we multiply back 1 over sine x, it will also give us the original equation. So in this case, the strip out sign remains in the denominator and it won't do us any good for the substitution of u is equal to cos x. So since this substitution requires a sign in the numerator of the quotient, also note that while we could convert the signs to cosines, the resulting integral would still be a fairly difficult integral. Okay, for the conclusion, so we can use the methods we applied to product of trigonometric functions to quotients of trigonometric functions provided the term that needs parts stripped out in is the numerator of our quotient from here. Okay,